small font.
Oh,
Don't worry about it.
Really bad.
okay. So the next thing we had to consider was actually
Next thing to consider was surfing.
Let's consider surfing. I'm all for it. What do I do now? Okay. Okay.
Yep. Thank you. So then we have this posting frequency representation, which on the one hand gives us signal. On the other hand, when we're looking at content, it's a problem. So say we're trying to predict across weekly patterns. It might break down like this. We have weeks with no data. We have gaps. We have weeks with few posts. Does it really mean the same thing when we assess one post in a week as it does when somebody posted 20 times? Is that telling us the same amount of information? Most time series analyses assume you can break time down into equal size pieces. And then, of course, we have many posts sometimes where we're probably getting a lot of information from a user within a given week. Of course, the goal, though, isn't just to measure posts over time, measure content over time. Really what we're trying to get at is a person's latent state over time. So their message is just, when I look at it, a noisy signal into the person's latent state. And that's ultimately what we're trying to get at, I think. And so, well, one solution to this is just to take users who have frequent post rates. And we did do a little bit of that, but when we restrict it to, we want a good estimate every week by that point. Just because post rates fluctuate so much, we're down to really only a few users. So instead, we look into interpolation, where the idea is to fill in the missing gaps and to, when we don't have enough information, to smooth based on surrounding data or, in the ideal situation, our expected pattern from the user that we've estimated over time. So we started simple with what we're calling KNN interpolation, which basically just says, for any given week, if I don't have at least K posts in that week, give me another post, the next nearest post. In this case, preceding the week we want, which makes it clean when we do some forecasting in a little bit, that we didn't look into the future. And so we keep adding the posts till we reach K, and then that week's estimate is the mean of that. So that's, because we partially wanted to get past this step into some other steps, we did a lot of what we're showing you today, we'll use this. But we also started to look into, and are continuing to look into, a Gaussian process, which is like a nonlinear, in basic terms, a nonlinear regression. The advantage is it can find cyclical patterns. It's basically using a kernel function, kind of an expected shape, to say what is the similarity between points, and it can project, for example, when we have gaps, not a lot of variance, but we still see some of the cyclical pattern happening. When we have a lot of data, it gets more accurate estimates. And this is kind of our first steps towards that. You can see it also gives us a confidence bound. It's giving us a distribution, not just the mean, but the variance expected. As this one's currently tuned, it's probably not representing what I just presented that we wanted, which is tracking somebody's latent state. We wouldn't have such a large variance, but we're getting there with that. You can see here a user that's not posting as much, defaulting to the mean. So we're getting this kind of, in general, this expected behavior. So we've now talked about how we're going to interpolate the data to see it continuously over time. Now let's talk about what actual content we're going to measure, which we didn't choose arbitrarily. And Glenn is going to go over that.